In this video, we're going to look at scale factor enlargements given a centre of enlargement. I'm going to start off by drawing an isosceles triangle. I'm going to have one of the vertices just here at 3, 2. I'll have another one at 4, 2, and then the final one at 3, 3. If I connect these up now, I'll have a little right angle triangle, and I'm going to label this shape A. So if you're in an exam, you might be given this as shape A. So let's just write this on. What I'm going to do is choose a scale factor enlargement, and I'm going to choose a centre of enlargement. You'll be given those in an exam. So what I'm going to do is map shape A to shape B, and I can write that like so. So A is going to be mapped to B, the scale factor enlargement is 2, and the centre of enlargement I'm going to choose now as 2, 1. So both of these I've just chosen. If we put this on, we're going to have the centre of enlargement just here at 2, 1. X is 2, y is 1. There are a couple of different approaches that you could take now to carry out this question. The first is to use guidelines, the second is to use vectors. I prefer to use vectors, but we will look at using the guidelines as well. So what I'm going to consider now is the following. I'm going to look at the centre of enlargement, I'm going to look at the vertices of the shape. I can either say to myself, how have I got from this point to this one, or how have I got from this one to start off with. I'm going to go from the centre of enlargement at 2, 1 to this vertex. I've gone across 1 and up by 1. As a vector, we would say that that is 1, 1. If I'm applying a scale factor stretch of 2, instead what I need to do to draw shape B is 2, 2. If this was a scale factor stretch of 3, or scale factor enlargement of 3, I should say, then it would be 3, 3, 4, 4, 5, 5, and so on and so forth. So this time I'm going to move 2 across and 2 up, and this vertex is mapped here. If you're confident at this stage, you can simply go ahead and redraw the triangle twice the size with the vertex starting here. So we could go up by 2, we could go across by 2 and then connect up. If it was a scale factor of 3, the shape would be 3 times bigger and 3 times further away. Let's say we weren't confident to do that, so what I'm going to do is choose another vertex. This one just here. Right by 2 and up by 1 is the vector here, 2, 1. Doubling this up, 4, 2. I move right by 4 and up by 2, and this vertex is mapped to this one. Clearly we can see now this one will be mapped here, as the shape must stay the same. It's not distorted in any way, and we can go ahead and connect that. Again, you could use the vectors to find this point right here. So labelling this one up, this is shape B. So it's twice as big and twice as far away from the centre of enlargement as A. I'm going to check that my work is correct by using guidelines, and we will see just how this works if you're going to use this method only. From the centre of enlargement, through the vertex of the smaller shape, and the vertex of the larger shape will be on that line. The same with this one, through here, and it will follow like so. Remember, these shapes are proportional, and that one and that one. The only reason I don't like to use this is I can't visually see it as easily, and also I'm prone to making errors. What I'm just going to do before we move on is look at mapping B to A. If I map B to A, the scale factor is going to be positive 1/2, and again the centre of enlargement will be 2, 1. A common error is to say negative 1/2. It's not. If we have a negative, the shape will be the other side and the orientation. So the way in which which way round it is changes. So if you've got a negative, it's back through the point. A positive will be the same side as the centre of enlargement. Okay, let's draw another shape. I'm just drawing these as I go, so hopefully they should all work. Let's do one now. Let's go for 3, 5. What I'm going to do is draw a square on this one, I think. So we'll have 3, 5. Let's do a 3 by 3 square. So that looks to be a 3 by 3 square. I'm going to call this shape A. This is just a bog standard 3 by 3 square, and we're going to look at applying, again, a positive scale factor, but this time we're going to look at a fraction. So what we'll have is a, and I'm going to map a to a primed or a dashed. So a to a dashed. So in an exam you might be asked to do this. What we're going to have this time is a scale factor, and I'm going to choose this to be 1/3. And I'll have now a centre of enlargement. So centre of enlargement, and let's go for 0, neg 1. So 0, negative 1. If I put this one down here, that is the centre of enlargement. If I'm applying a scale factor enlargement of 1/3, it's going to get 3 times smaller and 3 times closer to this point. So different ways we could approach this. Again, guidelines if you like. I'm not going to use them, but we will apply them afterwards. If I look here, I've gone across 3 and up by 6 to get from the centre of enlargement to this vertex here, across by 3 and up by 6. So the vector, right 3, up 6. If we've got a scale factor of positive 1/3, we need to divide both of these now by 3, and that's 1, 2. So we move to right 1 and up by 2. So this point now is mapped just here. If I look at this one, again, if you want, you can go ahead and draw the square. The square is just going to be here. And if you've got your guidelines, it might help you from there. I'm just going to consider this one. This has gone across 6 and up 6. So the vector is 6, 6. Therefore, dividing by 3 to 2. So we go across from the centre of enlargement, across 2, up 2. And then hopefully you can see that this point right here goes 3, and then we've got 9. So let's just put this on. So 3, 9. So this is going to be 1, 3. And of course, that point will go just here. And we connect that up, and we call this A dashed or A primed. So that can be drawn up like so, and we can show the vectors that we've used now to map it. So it's 1/3 of the size, and it's 3 times closer to the centre of enlargement. Again, if you want to use guidelines, pick the vertices, so it'll look something like so. As you can see with this, it's only as accurate as I draw it, and this is another reason, whilst I appreciate its use, I'm not always fond when I'm actually carrying out these transformations. I like it when I'm actually naming them, but to draw them, I find it easier to use vectors. So that's what we end up with. Scale factor of 1/3, centre of enlargement now is given to be 0, negative 1. Of course, from the last one, if we map A dash to A, scale factor of positive 3, it's simply the reciprocal of this fraction. The reciprocal is turning the fraction upside down. So 3/1, and again, centre of enlargement will be 0, negative 1. Both of these examples we've just done have been positive scale factors. We can see now that these are both the same side of the centre of enlargement. What we're now going to do is look at some negative scale factor enlargements, and they will be the other side of this centre of enlargement. So let's have another shape. Let's go for a rectangle this time. So I'm going to draw a rectangle, and we'll go for 4, 3. So if I put one vertex just here, we'll do 4, 3. Let's make it a 4 by 2 as well, and we can apply A. I'm just choosing these. So don't, if you're wondering where they're coming from, they're just coming from me thinking rather than there being anything special about them. I'm just choosing them, and I'm choosing all of the things that I'm doing with them, so all of the different transformations. Remember, with your transformations, you have rotations, reflections, translations, and enlargements. Later on, we will look at naming a single transformation, and it is important that you remember that these are enlargements. So what I'm going to do, let's map A to B again, A to B, so A to B. This time I'm going to have a negative 1/2 scale factor. So scale factor is -1/2, and let's choose a point of centre of enlargement. Let's go for centre of enlargement 2, 1. So if we just put this on, so I've just chosen those again. So 2, 1 is just there. With this one, you might want the guidelines. To begin with, the guidelines can really help. Again, I prefer to use vectors. What I want to do is think, how have I got from this point to this point right here? So I've gone left by 2 and down by 2. So if I look at this now, left by 2, so that's going to be -2, then we're going to have -2. I'm going to divide these by 2. The negative just means I'm going through the point. So what I'm going to have then is -1, -1. So what I'm going to do is go from here, left 1 and down 1, and this point right here gets mapped here. Don't fall into the trap of drawing the next one just here. The shape is going to actually end up down here, like so. Let's look at this one. I've gone now to the center. Remember, this is our center of enlargement. It's probably, in fact, let me change these over to make it slightly easier. Let's put that just. So what have I done? I've gone now left by 4 and down by 2. So let's put this here. So left by 4 and down by 2. So what I need to do is go left by 2 and down by 1 from the center of enlargement. Left by 2 and down by 1. If you want, you can try this one. And what have I done? I've gone left by 2 and down by 6. So left by 2, down by 6. So dividing these by 2, left by 1, and then we're going to go down, dividing this by 2, -3. So we can end up with that point here. So this point maps just here, and then we're left with the easy task of putting that one in. Again, depending on how confident you are, you could have done that a lot earlier. But this now gives us the negative scale factor stretch of 1/2, and it's through the center of enlargement, and that center of enlargement is 2, 1. Let's label this up as B, and a nice way to check that we've done this is to get the guidelines on. So if we look at this one, we go through like so. If we look at this one right here, we go through like so. If we look at this one right here, we go through, so that comes to here, and then this one comes to here. You can, of course, extend these guidelines, and this shape will just keep going. So if I just extend this one. But again, I prefer to go for the method of where we're considering vectors, as I think it's, firstly, it's more intuitive, so it's natural to think, how am I going to do that? And also, it avoids me making errors. I can't always see this particular method. So that's what we've got. So this is a -1/2 scale factor enlargement, center of enlargement to 1. So if we wanted, of course, to go from B to A, we would have the reciprocal, so it'd be -2/1 or -2, scale factor, center of enlargement to 1. So that's quite a nice one. That's a negative, and it's a fraction, so quite a toughie. Right, let's do another one. Let's draw another one, and we will draw a little square. So this time I'm going to have, let's go for, we'll do 3, 5. Let's put on 3, 5. So we'll go just here and draw something. So let's draw this 3, 5, 3, 6, 4, 5, 4, 6, and we will just connect all of this up. So what's this look like? Let's try a different color. We will have black. So we'll call this one A, and we'll map this to A dash. Again, I'm going to choose the transformations. You will be given them in the exams. So let's call this A. What I'm going to do is map A to A dash. So this again is an enlargement, A to A dash. So A to A dash enlargement, we're going to have a scale factor, and let's try -3, and let's choose the center of enlargement to, and we'll give it the coordinates 6, 4. So let's do that. Let's see where 6, 4 is. So 6, 4 looks to be just there. So we got a negative, so we're going to go back through the point. If at this stage you want to do your guidelines, you can do. I'm not going to do them again. I'm just going to consider the vector. So if I look at this one, I've gone right 2 and down 1. So if I write this, my vector is right 2 and down by 1. Scale factor of -3. So we're going to multiply up by 3. So what I'm going to have is across 6 and down by -3. So we go across 6, which is just here, and down by -3, or down by 3, I should say. And that will be just here. So that one is there. This one, I've gone across 3 and down 1. So 3, -1. That's going to give me 9, -3. So if we went 9, -3, we know that's going to be here. At this point, you can, of course, draw the square. I'm just going to, again, take a point just here, This one right here has gone across 2 and down 2. So this is going to be 2 neg 2. So we're going to get 6 neg 6. So if we think about it, there's our 6. Negative 6 is going to take me down to this point right here. So let's go down with that one, and that'll be just there. And then finally, we can just draw on the other one. So if we just do this, what we're going to have is something that looks like the following. So it goes like so, 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 and then we're going to match these up. Let's just go ahead and do that. So what we're going to have is A dashed. So that is going to be A dash. There is our centre of enlargement. And just to check, we can go with our guidelines. So if we look now, again, that's only as accurate as I draw it. This one right here, that will point to that one. This one right here, again, map into this one here. And then finally, we'll have this one map into here. I still think it's slightly harder doing it this way, but it's entirely up to you. So that now is mapping like so. So if we wanted, of course, to go from A dash to A, the scale factor is going to be negative 1/3. And again, centre of enlargement will be 6, 4. So that is done, all sorted. So that is applying an enlargement. So we've been asked to apply them. Sometimes we might be asked to say a single transformation that takes one shape to another. Remember, with your transformations, you're going to either have a rotation, a translation, a reflection, or an enlargement. So what I'm going to do now is draw another shape. Let's just draw another shape on here, and we'll go for 3, 2. Let's put a vertex just here. Let's put one just here. Let's put another one just here. So that's going to give me a shape. This is just a basic right angle isosceles triangle, and we will call that shape A. So let's just label this up A, and then what we're going to have is A dashed, and I'm going to put A dashed somewhere over here. Let's go ahead and just put A dashed. So let's see if I can make this work, because I'm kind of making these up as I go, so hopefully it'll work. So what are we going to have? Neg 4 1, neg 3 1, and let's put neg 3 2. So this is going to be A dashed. This is where your guidelines really become quite useful. So we're going to state fully the single transformation that maps shape A to A dashed. So stating it fully. So let's state fully. So it's a single transformation. It's just one transformation. The first thing I'm going to state is that it's an enlargement. We can tell that it's an enlargement because the shape has changed in size. A translation will only move it. A rotation will only move it, and a reflection will only move it. The only thing that's going to make it bigger is an enlargement. What I need to do at this stage is state the scale factor and also the centre of enlargement. And the way that I'm going to do this is with the guidelines. If you go ahead and put these on and mess it up, it doesn't matter. All I'm going to do is put the guidelines on, and we will see something like so. So we can see quite clearly that this is not the correct vertex. So by putting these on, I've got the wrong vertices. What we need to make sure is that we're mapping the correct vertices to one another. Even if it takes you a couple of goes, don't worry. So what we'll have is something now, if I put this on, and it will do something like this. So again, if you're unsure, just go ahead and put the vertices now through with these lines, and wherever they meet is our centre of enlargement. So we can see that's the centre of enlargement. It's where these all cross, and that point right here is -1, +2. So I'm going to write here centre of enlargement, and we've done that by using the guidelines, and that is going to be -1, +2. Let's now think of the scale factor enlargement. The shape is half the size, and it's back through the point. Being back through that point means it's going to be now negative, and we can see that A to A dashed is going to be 1/2. If we were asked to state fully the single transformation that maps A dash to A, it would be -2. We're doing A to A dash. So there we go. State fully the single transformation that maps shape A to A dash. I've used those broken lines or the guidelines. I've found where they meet, and all we've done is located the centre of enlargement from there. So there we go. That is scale factor enlargements given a centre of enlargement. We've looked at applying them and also naming them.